Hey everyone, welcome back to Tech with Zui. So in the previous part, we saw that we were using extra space to find the frequency of all elements that occur more than n by 3 times. There's a better algorithm for this. So the observation of this algorithm is the list of majority elements can have at most two such elements which occur more than n by 3 times. So suppose an array has n elements and we want to find elements that occur more than n by 3 times. So let's say you have x such elements and then each of them appears more than n by 3 times. For this condition to be true, we'll have to put it mathematically like this. So x are such elements which occur more than n by 3 times. So that's why I've added 1 here. And this condition should be like less than equal to n because it should not exceed the total number of elements, right? So considering this, the conclusion is maximum value that x can achieve is less than 3. So that is 2. Right? So if you have an input like this, you know that there are only going to be two majority elements. And using this algorithm, you're going to find the potential majority elements. So you have two variables, element 1, element 2, for the actual elements, and count 1, count 2 for keeping a track of the count. So initially, when we start iterating, we are at 2. So we keep element 1 as 2 and increment its count. Again we encounter a 2, so we still haven't got another unique element, distinct element yet. So element 2 is still minus 1, but count 1 has been incremented because 2 has occurred twice. Now we got a 3. So element 2 is 3 and we increment the count 2 as well. But as soon as we got another potential candidate over here, we decremented the values of the count 1 and count 2. So we keep doing this until we find the potential element. So if you observe here, at last 2 and 1 are the potential candidates. Now these are just potential candidates. Actual count we still need to validate because if you remember, we decremented counts as well, right? Once you have the potential candidates, you have to check if the actual count of element 1 is actually greater than n by 3 and element 2 is also greater than n by 3. If yes, you have to add that to the list. And optionally, you'll also have to sort that result list if it's asked in the question. The code for it will look something like you have element 1 as minus 1, element 2 as minus 1, count 1 and count 2 initialized as 0. You keep checking if you encountered the same element 1, and then increment the counter for each of them. Otherwise, you found a new candidate 1, new candidate 2. If neither candidate, decrement it. Like we found 1, so we decremented it. And then you have to find the actual count of element 1 and element 2 after finding the potential elements. And then optionally you have to sort it. That's how you have to approach this question. Thank you.